Hi, everyone. This is last example of proof by contradiction. The statement, and this is from your textbook, is if x and y are positive real numbers and x does not equal y, then x plus y is greater than 4xy divided by x plus y. It's important to make the quantifiers explicit. This is equivalent to saying that for all real numbers x and y, if x and y are positive and x does not equal y, then x plus y is greater than 4xy over x plus y. Why is that important? Because you have to assume the negation is true. So we're going to assume for our proof by contradiction that there exist x and y in the real numbers such that P is true and Q is false. So such that x is greater than 0 and y is greater than 0 and x does not equal y and Q is false. X plus y is less than or equal to 4xy over x plus y. Now, you have all these things are true. We're going to play with some of these to try to reach a logical contradiction, which again is a contradiction of some known fact. I think the most logical thing to do is to play with the last piece. We're going to multiply, because x and y are positive, we can multiply both sides by x plus y. Okay, so from this right here, we know that x plus y squared is less than or equal to 4xy. And then I'll expand that out. I know that x squared plus 2xy plus y squared is less than or equal to 4xy, which says if I subtract 4xy, that x squared minus 2xy, subtracting 4xy from both sides, plus y squared is less than or equal to 0. And then I can factor that. That's a perfect square. That is x minus y quantity squared is less than or equal to 0. Okay, now comes in the fact that what do we know about the other assumptions, okay? This leads us to two conclusions. Either x minus y quantity squared is less than 0, which cannot happen in the real numbers. Remember, if you square any number, be it positive or negative, you get something greater than 0, okay? So x minus y cannot be less than 0, okay? And what that contradicts is this contradicts x and y are real numbers, because only imaginary numbers, complex numbers, when you square them, give you something less than 0. Or we know that x minus y quantity squared equals 0, because less than or equal to says we know it's either less than 0. Well, that leads to a contradiction. Or it equals 0. Well, if it equals 0, then that says that x minus y equals 0 or x equals y. This contradicts the fact that x does not equal y, which again was one of our assumptions that it's true. So so we know that the negation cannot be true. So since the negation cannot be true, it leads to a logical contradiction. We know the original statement must be true. And the only other thing I might do to clean this up a little bit, I'll highlight it maybe in a different color, such as blue, this C. So is from appearances, it doesn't look like we've used that. It actually has. I would say that's really the first line, because x is positive and y is positive. I would say since x and y are greater than 0, x plus y is greater than 0. So, and that's what allows us to multiply both sides by x plus y and not change the inequality. Anyways, that is your proof, your example of a proof by contradiction. We will do more of those in class, and look forward to seeing what you can do. Thanks.